Welcome to podcast 1.1. The first podcast talks about numbers. And a lot of chemistry is math, and y'all are actually pretty good at math, the multiplying, dividing, and stuff like that. What usually hampers students in chemistry is, well, what do I do with that number? Do I multiply or divide? It's a word problem. What am I supposed to do? I need some help. So hopefully I'll show you a couple things along the way. I do want to point out a couple things to you, mainly in terms of significant figures. Do me a favor. Go get your calculator. Go ahead and hit pause now. Go get your calculator. Okay, you didn't go get it. Go get your calculator. The guy in the back. Yeah, you still didn't get it. Go get it. All right, good. Now, you got your calculator. Do me a favor. How many inches tall are you? Me, I'm 5'8". That's 68 inches. Well, when's the last time I measured myself? Probably 15 years ago. So, am I exactly 5'8"? How much confidence do I have in 5'8"? Well, do me a favor. Take your height in inches, however tall you are. I'm 68 inches. And go ahead and multiply it by 2.54. And let's see what happens. All right, so here I am in my calculator, and I'm 68 inches. 68 times 2.54, and let's see what happens. Let's see what it says. I'm 172.72 centimeters. Well, how long is a centimeter? Well, it's not very long at all. I mean, if you've ever looked at a ruler. So let's look at this number for a second. See right here? Now, how sure am I of this? How sure am I of my height? How sure are you of your height? Look at your answer. See what your answer is. Am I sure to a single centimeter how tall I am? Oh, I don't know. I'm 5'8". Well, maybe 5'8.5". I don't know. Maybe. I don't really know. What about the 7th one? This is in the 1/10th place. In the 10th place, you got a problem because a tenth of a centimeter is a millimeter. I mean, look at a ruler. A millimeter is very tiny. Do I think I know how tall I am to the 10th of a millimeter? I'm going to say no. To the 100th, the 2 right there. Do I know to the 100th place for sure what my height is? Well, of course not, because I haven't, measured my height in 10 or 15 years, so I probably don't know for sure. So what part of this number do I have faith in? What part of the number is significant? Well, this 7 and 2, no. This 7 and 2, maybe. The 2, maybe. But you know what? If I was 5'8.5", then I would be like 173 point something centimeters. So I really don't have a lot of faith in 172. I'm just going to say 170. Now, if I had a good ruler that measured to the millimeter, like this is, I could actually measure my height, write down an answer that I was this certain of. But I'm not. Because, you stand up against a door and someone measures you, or you go in the doctor's office and someone measures you. So I'm not going to tell you I'm 172.72. That's a lie. I am going to tell you that I'm 170 centimeters. Okay? 170 centimeters. So I'm just going to go backwards right here. I'm going to divide that by 2.54. And I'm going to see how many inches that is. Okay. Well, that's 66.9 inches. I can live with that. Okay. And I'm going to divide that by 12 to figure out how many feet I am. So I'm 5.5 feet tall. Well, a little bit better than 5.5 feet. Well, that's okay. Because I am. That's fine. So I'm good with 170 centimeters. So it all comes down to how many numbers are significant. 2.4 is not the same thing as 2.40. Okay? And I'll show you that in a minute, why that's true. We already did the how tall you are thing, but we're going to need rules for significant figures. So how can we figure out in a number how many digits we want to believe? How many of them have meaning? You have a set of rules for significant figures. So you probably want to pause and go ahead and write these down in your notes. It's very, very simple. Non-zeros, that one's simple. Look at your number. To the right of the decimal, is there a 0 at the very end of the number? Not just to the right of the decimal, but at the very end. Well, why does that matter? Well, if you wrote 2.50, well, what's the reason? Why would you include the 0? Why not just read 2.5? Well, because when you say 2.50, you're saying I'm good not only to the 10th place, where the 5 is, I'm good to the 100th place. I have a good enough measuring device that I can figure out exactly how long something is. So that works. The third one is, how many sandwiched zeros are there? In other words, how many zeros are there sandwiched between two significant digits? All right. There is one but, one caveat, or a time when we get to forget these rules. Anytime you count something, or anything that's a definition, gets unlimited sig figs. So in other words, go to your room, count the number of shoes in your room. 1, 2, 3, 4, 5, 6, 7, 28. I have 28 shoes. Well, did you round that 28 shoes? I don't really think you had 27 and a half shoes and you rounded up. I really don't think you had 28.23 and you rounded down. Let's be honest, when you count something, you're going to be dead on in how many there are, right? Because it's not a measuring device where you take out a ruler and say, how many shoes do I have? You count them. Anything that's a definition, so 12 inches is a foot and those kinds of things, we say have unlimited sig figs as well. All right, so how many sig figs is this? Go ahead and pause and write down what you think your answer is based on these rules, okay? And I'll give you the answers in class. So you go through and figure out how many sig figs this is and bring those in. Make sure that you write down the number and then how many sig figs it is, and then we'll compare in class, okay? Then when we do math with significant figures, there's two rules: when we multiply and divide, and when we add and subtract. We have a set of rules that we use, all right? If you guys will get these rules down in your notes, then I will show you how to use them in class, okay? How do you actually do the math? All right, so I would love for y'all if you would go and actually have a look at this YouTube video. I think this is just beautiful. It's embarrassing, but go look at the YouTube video and it'll help you get a leg up on what you're doing. I'm going to go ahead and show you, though, why certain numbers are significant and why are not. Because I asked you at the beginning, 2.4 and 2.40, what's more significant? So I'm going to try this out. This is a new little pen thing for me, but let's see how it works. So, all right, so we want to start in here. Let's pick a color. What color should we pick? This is my new little patty thing, so let's see. Let's go light blue. All right, so let's look at the numbers. 2.4, 2.40, and 2. Let's, how are these any different? Well, you can round 2.40 to 2.4, and you can round 2.4 to 2. So they're all the same number, correct? Well, not really, because let's look for a minute. Let's think about what could have been the numbers that you got and then you rounded to 2.4. So let's think about that for a minute. What's the low end of what it could be to round and get 2.4? Well, you could have 2.3. Oops. You could have 2.35. That would work. It's 2.35. And what could it be on the big side? Well, this could be anywhere up to 2.44. All of those numbers basically round to 2.4. So all of a sudden, if you have the number, let's say 2.35, well, is that the same number as 2.40? Well, of course not. When you look at it that way, you think, no, it's not even possible. Well, what about 2.42? Is that the same thing as 2.40? Well, no. So when you look at a number, the reason why this one down here with the smile, let's see if I can put a smiley face in it, if this one down here, no, that's not it. Let's see if this one down here, that I'm going to try to put a smiley face in. That's not working. All right. Is 2.40. The reason why that has a 0 is because we are sure not only to the 10th place down here, but to the 100th place. The 100th place. We're sure what our measurement is. We feel confident and repeatable that, hey, this is going to work. This one we're not. We're only confident to the 10th place. So we round whatever answer we have to that. This number right here, we're only confident to the ones place. And let's think about it for a second. Let's go red, right? We'll do red this time. All right, so what numbers could we have rounded to get to 2? Well, it could be as low as 1.5 and as high as 2.4. Now, 1.5, 2.4, those all round to 2, but you would not say that 2.4 is the same thing as 2.40. You wouldn't say that 1.5 is the same thing as 2.40. We are only confident to the ones place right there of the measurement. Okay, so let's say you're measuring your room. Okay, so get out a ruler and measure your room. So you get out a ruler and you measure it, and it's I don't know how big your room is. Just for fun, we're going to say it's 172.4369 inches. Okay. Well, how much of that number do you want to believe, right? Well, probably not that. I think that's a lie. I'm going to call you a liar. And probably not that. That's probably a lie. And really, probably that. I don't think that your ruler was that good. I'm going to go ahead and guess that probably not even that is correct, because you've got to move your ruler around and there's a lot of error. And so maybe 127. Maybe you didn't do a very good job. Maybe you just kind of fudged it a little bit. Maybe you want to say 130. That would be totally okay. But the 127 has 3 sig figs, or 3 significant figures. The 130 only has 2. This one's significant, that one's significant, that one is a placeholder. And because it's a placeholder, we don't want to believe it at all. I mean, it's got to be there, but we don't want to place any significance with it. You may have done a really horrible job, and you might want to say 100 centimeters or 100 inches because you just guessed. Okay? And that would probably be okay as well. It just tells you how sure of your answer are you. Now, if you had a laser and you were able to measure it, then that's fine. Then maybe you can know that that's exactly how big your room is. So it just really comes down to, how sure of your number, how sure of your measuring device are you? And this is where we run into stuff in Chem Lab. You got a beaker, and you've got, let's see, what else? A graduated cylinder. I don't know if I can draw this, but good enough. And you've got a pipette, a super small pipette right here. Okay. Now, do they all hold liquid? Sure, they all hold liquid. But which one is best for measuring liquids when you want to be exactly sure? Well, this thing has all kinds of lines on it. Lots and lots of lines. And those lines probably correspond to the 10th place or even the 100th place. So you're talking about 0.1 or 0.01 depending on it. This graduated cylinder right here, it reads to the ones place. Okay? So the beaker reads to the tens place, or sometimes even like the hundreds place. So you're talking here it's 10 or 100. So if you're going to measure out just some water, I just need some water, then use a beaker. But if you want exact amounts of anything, then you're better off using a pipette. All kind of depends what you're doing, right? If you're building a road, you don't want to measure things with a beaker because you want the road to end up in the right place. You don't want to have it end up all screwed up. All right? So hopefully I've been able to convince you that 2.4, 2.40, and 2 are not all the same number. Accuracy versus precision. And accuracy is if you weigh something and you actually got what it weighs. Yay, you got the right answer. Yay for you. So when you get an answer, you want to say, well, how close am I to right? Kind of like throwing a ball at a target. You want to know how accurate you are. And accuracy is very important in chemistry. We hope that if you went in and used a balance in the lab, that you would use any of the 8 that we have in lab and you could weigh something and get the correct value. But the other important thing is precision, right? And precision is if you went in and weighed the same object 57,000 times, would you get pretty much the same value every time? And precision is important because if you go in and do a lab, or your friend goes in to do a lab, or some guy off the street goes in to do a lab, you want to know that the measurements that you get are repeatable, meaning doesn't matter who does it, you can always get the same values. So we can't just write down all the digits we feel like writing. We have to rely on the equipment that we have.